In September 1946, the most beautiful diesel locomotive ever built rolled into New York's Waldorf-Astoria hotel. The Santa Fe PA-1, painted in stunning red and silver warbonnet colors, sat on a private railroad siding while railroad executives and journalists gathered to witness what ALCO promised would be the future of American passenger travel. 2,000 horsepower. Streamlined curves that made EMD's E-units look like boxes on wheels. The locomotive that would finally break electromotive stranglehold on the diesel market. Within 2 years, that beautiful machine would be demoted from Santa Fe's premier passenger trains. Within a decade, most PA-1s would be relegated to secondary service or scrapped entirely. Within 23 years, the American Locomotive Company, a manufacturer that had built locomotives since 1901 and steam engines since 1848, would close its doors forever. The culprit wasn't the locomotive's stunning exterior. It was what lurked beneath that beautiful skin. The ALCO 244 engine, a prime mover so rushed into production, so plagued with failures, that it destroyed a century-old company's reputation in less than 3 years. By early 1948, ALCO had spent $4.3 million on field repairs alone. 600 engine blocks had to be replaced. Crankshafts snapped without warning. Turbochargers failed repeatedly. Brand new locomotives were being towed back to shops before they'd completed their first month of revenue service. This is the story of how America's oldest locomotive manufacturer bet everything on an engine that wasn't ready and lost. To understand why ALCO rushed the 244 into production, you need to understand the terror that gripped Schenectady in 1944. The American Locomotive Company had dominated American railroading for decades. They'd built the Hudsons that pulled the 20th Century Limited. They'd built the big boys that conquered Sherman Hill. They'd built more steam locomotives than any American company except Baldwin. Their reputation was unassailable. But the world was changing. EMD's FT demonstrator had toured American railroads in 1939, and the message was clear. Diesel was the future. Steam locomotives required water towers every 100 miles, coal chutes, ash pits, roundhouses full of specialized equipment. Diesel locomotives could run coast to coast with nothing but fuel stops. The economics were devastating for steam. ALCO had diesel experience. Their RS-1 road switcher, introduced in 1941, was genuinely innovative. The first true road switcher design. Their S-series switchers sold well. But these locomotives used the Model 539 engine, a reliable but limited design that couldn't produce the horsepower needed for mainline passenger and freight service. EMD, meanwhile, was eating the market alive. Their 567 engine, so named for its 567 cubic inches per cylinder, was proving bulletproof in service. The F units that carried it were selling faster than Lagrange could build them. Every month that passed, EMD's dominance grew stronger. The contrast between the two companies couldn't have been starker. EMD had developed the 567 carefully, testing it exhaustively before putting it into production locomotives. When the FT demonstrator toured American railroads, the engine beneath its hood had already proven itself in thousands of hours of operation. Railroads that bought F units got machines that worked from day one. ALCO watched their market share erode with every EMD sale. The company that had built locomotives for nearly a century was being displaced by an upstart that had barely existed before the Depression. Pride and panic combined into a toxic mixture that would prove fatal. ALCO's management made a fateful decision. They would develop an entirely new engine capable of competing with the 567, and they would get it into production before the end of 1946, no matter what. The 244 engine was named for the month its design was finalized, February 1944. It was a clean sheet design, a turbocharged 4-stroke V engine that would be offered in 12 and 16-cylinder configurations. The 12-cylinder version would produce 1,500 horsepower for freight service. The 16-cylinder version would deliver 2,000 horsepower for passenger locomotives, matching EMD's best. On paper, the specifications were competitive. The bore and stroke were 9 inches by 10.5 inches. The engine could run at 1,000 RPM at full power. The turbocharger, supplied by General Electric, would boost output beyond what naturally aspirated designs could achieve. But paper specifications don't reveal what happens when metal meets reality. ALCO's engineering team knew the 244 needed extensive testing. Diesel engines for railroad service face brutal conditions, constant vibration, extreme temperature swings, thousands of hours of continuous operation. Problems that might not appear in 100 hours of bench testing could prove catastrophic after 1,000 hours on the road. Management didn't care. The deadline was the deadline. In August 1945, with the first engines barely beginning their test program, ALCO began tooling up for production. By October, engines were being shipped from the Auburn plant to Schenectady for installation in locomotives. By January 1946, the first FA-1 freight locomotives were being assembled, before the 244 had completed even basic validation testing. The first engine shipped to Schenectady went onto a test stand in Building 37. The 600-hour endurance test began on November 23, 1945. It concluded on December 17th with 6 shutdowns to fix problems that emerged during testing. 6 shutdowns in 600 hours, 1 failure every 100 hours of operation, and ALCO's sales department was already taking orders. The failures began almost immediately. Gulf, Mobile, and Ohio had placed a standing order for 80 freight locomotives, FA-1s and FB-1s, powered by the 12-cylinder 244. They were among the first customers to receive production units. Within months, they were among the first to experience catastrophic engine failures. The crankshafts were breaking. ALCO had originally specified cast iron crankshafts for the 244, cheaper to produce than forged steel, adequate for the design parameters on paper. But cast iron couldn't handle the stresses of actual railroad service. The crankshafts cracked, sometimes while the locomotive was pulling a train. Failed cranks meant dead engines, stranded trains, emergency repairs, and furious customers. By mid-1946, ALCO switched to forged steel crankshafts. Problem solved, they thought. The forged crankshafts kept breaking too. This time the problem was traced to a supplier providing components with metallurgical flaws. Quality control had failed at multiple levels. Crankshafts that should have lasted for years were failing in months. The first 20 engines installed in GM and O locomotives had to be completely rebuilt with new crankshafts at ALCO's expense. But the crankshafts were just the beginning. The 244's problems cascaded through every major system. The main bearing saddles, the structural elements that supported the crankshaft within the engine block, were welded to the block itself. The welding procedures were inadequate. Cracks developed at the weld joints, allowing the bearings to shift microscopically. Shifted bearings meant accelerated wear, overheating, and eventually catastrophic failure. ALCO replaced approximately 600 engine blocks due to welding defects. 600 blocks. Each replacement meant pulling the engine from a locomotive, shipping it back to the factory, installing a new block, and returning it to service. The logistics alone were staggering. The General Electric Turbocharger was another disaster. The RD-1 unit was air-cooled, and it couldn't handle the heat generated during sustained high-power operation. The turbine housings cracked. The manifolds failed. The turbocharger's acceleration characteristics were poor, creating a lag between when the engineer called for power and when the engine actually delivered it. Locomotives would belch enormous clouds of black smoke during acceleration, unburned fuel dumped into the atmosphere while the turbocharger spooled up. Rail fans loved the smoke. They called ALCO diesels honorary steam locomotives and chased them with cameras. Railroad mechanical departments were less amused. That smoke represented wasted fuel and incomplete combustion. It represented an engine that wasn't working properly. GE redesigned the Turbocharger repeatedly. The RD-1 became the RD-2. Problems persisted. Finally, in 1953, GE introduced a water-cooled RD-3 turbocharger that actually worked reliably. By then, the damage was done. The PA-1 became the poster child for the 244's failures. ALCO had positioned the PA as their flagship, a direct competitor to EMD's E-units in the premium passenger market. The locomotive was genuinely beautiful, with swooping lines and a streamlined nose that photographers loved. Santa Fe ordered dozens. So did Southern Pacific, Pennsylvania Railroad, Union Pacific, and a dozen other carriers. Then the engines started failing. On railroads that ran EMD E-units alongside ALCO PAs, the comparison was devastating. The E-units ran month after month with nothing but routine maintenance. The PAs spent weeks in shops waiting for replacement parts, rebuilt turbochargers, new crankshafts. Mechanical officers who had to keep trains running learned to schedule PAs for secondary assignments where their unreliability wouldn't disrupt premium service. Santa Fe, which had enthusiastically unveiled that first PA-1 at the Waldorf-Astoria, began demoting their ALCO power from the Super Chief and other premier trains. EMDE units took over the flagship assignments. The PA-1s that had promised to revolutionize passenger service were relegated to branch lines and secondary runs. The ultimate humiliation came in August 1954 when Santa Fe repowered their original PA-1 demonstrator set, units 51L, 51A, and 51B, with EMD 567 engines. ALCO's flagship locomotive, the machine that had been displayed at the Waldorf-Astoria as the future of railroading, was gutted and fitted with a competitor's power plant. The experiment proved economically unfeasible. The remaining Santa Fe PAs kept their 244 engines and were retired as quickly as possible. The financial hemorrhage was relentless. By early 1948, ALCO had spent $4.3 million on warranty repairs and field modifications for the 244 engine. In 1948 dollars, adjusted for inflation, that's roughly $55 million today, spent not on developing new products or expanding production, but on fixing engines that should have worked from the factory. The $4.3 million figure only captured direct repair costs. It didn't include the lost sales from customers who switched to EMD after experiencing 244 failures. It didn't include the damaged relationships with railroads that had trusted ALCO's reputation. It didn't include the opportunity cost of engineering resources devoted to fixing problems instead of developing new products. Most devastatingly, it didn't capture the reputational damage that would haunt ALCO for the rest of its existence. Railroads have institutional memories. The purchasing agents who wrote orders for PA-1s in 1946 remembered watching those locomotives fail in 1948. The mechanical officers who spent years fighting 244 problems remembered that frustration when evaluating ALCO's later products. Word spread through the industry. ALCO engines were unreliable. ALCO rushed products to market before they were ready. ALCO couldn't be trusted. EMD, meanwhile, kept building 5, 6, 7-powered locomotives that ran for years without major failures. Their F units sold by the thousands. Their market share climbed relentlessly. By the early 1950s, EMD controlled roughly 70% of the North American locomotive market. ALCO was fighting for second place against Baldwin and Fairbanks Morse. ALCO's engineers knew the 244 was killing the company. In 1949, with warranty claims still flooding in, they began developing a completely new engine design, one that would be tested properly before production began. The new engine was designated the 251. It shared the same bore and stroke as the 244, but incorporated lessons learned from every failure mode that had plagued its predecessor. The main bearing design was improved. The engine block structure was strengthened. The turbocharger was redesigned. Every system that had failed in the 244 was re-engineered from scratch. The 251 entered production in 1956, a full 5 years after development began. ALCO had learned its lesson about rushing engines to market. The testing program was exhaustive. The validation was thorough. When the 251 finally reached customers, it was genuinely reliable. Too late. Far too late. By 1956, the damage was done. EMD's dominance was unassailable. Railroads that might have considered ALCO products remembered the 244 disaster and ordered from Lagrange instead. The 251 was a good engine. It's still in production today, built by Fairbanks Morse, but it couldn't resurrect a reputation that the 244 had destroyed. There was another consequence of the 244 disaster that proved equally fatal. It destroyed ALCO's partnership with General Electric. ALCO and GE had collaborated on diesel locomotives since the 1920s. GE supplied electrical components, generators, traction motors, control systems. ALCO supplied the mechanical elements, engines, frames, trucks. Together, they'd built thousands of locomotives. The 244's turbocharger problems strained that relationship severely. GE's RD1 turbocharger was part of the failure cascade, and ALCO blamed GE for contributing to their difficulties. GE, watching ALCO's market share collapse, began questioning whether the partnership made strategic sense. In 1953, GE ended the collaboration and entered the locomotive market independently. They started with export models, building locomotives for railroads in countries where ALCO's damaged reputation hadn't spread. Then GE launched domestic production with the U-25B in 1960, a locomotive specifically designed to challenge both EMD and ALCO on their home turf. The U-25B wasn't perfect. Early units had their own reliability issues. But GE had something ALCO lacked: corporate resources to weather problems and fix them without destroying their reputation. GE was part of a massive conglomerate that could absorb losses while engineers solved problems. ALCO was a standalone locomotive manufacturer whose entire business depended on selling locomotives to customers Who remembered the 244? Suddenly, ALCO faced competition not just from EMD, but from their former partner, a company with deep pockets, excellent engineering resources, and no damaged reputation to overcome. By 1964, GE had surpassed ALCO in market share. The company that had supplied ALCO's electrical components for decades was now their most dangerous competitor. ALCO had fallen to third place in an industry where third place meant death. The end came quickly after that. ALCO introduced the Century Series in 1963, modern locomotives with the reliable 251 engine, competitive specifications, innovative features. The C628 was the first production locomotive with AC/DC transmission. The C636 matched EMD and GE at 3,600 horsepower. On paper, ALCO was finally competitive again. Sales remained anemic. Railroads remembered the 244. They remembered the warranty claims, the broken crankshafts, the locomotives that spent more time in shops than on the road. ALCO's salesmen could demonstrate that the 251 was reliable, that the Century Series was well engineered, that the old problems were solved. Purchasing agents nodded politely and ordered from EMD. In 1964, Worthington Corporation acquired ALCO. In 1967, Worthington merged with Studebaker to form Studebaker-Worthington. The new management looked at ALCO's locomotive division, still losing market share, still fighting against EMD and GE, still burdened by a reputation destroyed 2 decades earlier, and made the obvious decision. On January 9, 1969, the last 2 locomotives rolled out of ALCO's Schenectady plant, a pair of T6 switchers bound for the Newburgh and South Shore Railroad. 121 years of continuous locomotive production at Schenectady came to an end. The company that had built big boys and Hudsons and Challengers, that had equipped railroads across North America and around the world, was finished. The 244 engine didn't kill ALCO by itself. Market forces, management decisions, competitive pressures, and the end of the GE partnership all played roles. But the 244 was the wound that never healed, the self-inflicted disaster that destroyed ALCO's reputation precisely when it needed credibility most. The irony is that ALCO eventually fixed the 244. Late production versions with improved components were reasonably reliable. The RS3 road switchers, which used the 12-cylinder 244, served faithfully on dozens of railroads for decades. Some are still running today on heritage railroads and short lines. But railroad purchasing decisions aren't made on late production improvements. They're made on first impressions, on institutional memory, on the stories that mechanical officers tell each other at industry conferences. The story of the 244 was a story of crankshafts breaking, turbochargers failing, beautiful locomotives demoted to secondary service, while EMD power handled the important trains. That story killed ALCO as surely as any mechanical failure. The Schenectady plant was completely demolished by 2019, 50 years after the last locomotive left. The site is now an industrial park. Nothing remains of the factory that built locomotives for 121 years, except historical markers and fading photographs. But ALCO's legacy isn't entirely gone. The 251 engine that ALCO developed to replace the disastrous 244 remains in production today. Fairbanks Morse manufactures it for marine and stationary applications. The engine that came too late to save ALCO outlived the company by more than half a century. And somewhere on a heritage railroad, an old RS3 with a late production 244 engine still runs, a reminder of what might have been if ALCO had waited just one more year, tested just a little longer, resisted the pressure to rush an unfinished engine into production. The 244 wasn't a bad design, it was a design that wasn't ready. And in the railroad industry, where reputation is everything and institutional memory lasts for generations, that distinction doesn't matter. ALCO bet its future on an engine that needed more time. They lost that bet. And 121 years of locomotive manufacturing ended because management couldn't wait for engineering to finish their work. The lesson of the 244 disaster echoes through railroad history. Decades later, EMD would make the same mistake with the 265H engine in the SD90 Mac, rushing an unfinished design to market and destroying their own reputation in the process. GE would stumble with the 7HDL engine in the AC6000CW. The pattern repeats because the pressures never change. Competitors gaining ground, customers demanding new products, management demanding results, but ALCO was the first. They proved that in the locomotive industry, reputation is everything. and reputation once lost can never be fully recovered. The most beautiful locomotive ever built couldn't save a company that sold engines before they were ready. The trains still roll across America. None of them are pulled by ALCO locomotives fresh from Schenectady. That factory is gone, its buildings demolished, its workers scattered to history. All that remains is a cautionary tale about what happens when the pressure to ship overwhelms the discipline to test. The 244 engine killed ALCO, not because it was a bad design, but because it was a rushed design. And in an industry where trust takes decades to build and moments to destroy, that distinction made no difference at all.